Hello and welcome to the next edition of the HP Discover podcast series. I'm Dana Gardner, Principal Analyst at Inter Arbor Solutions, your host and moderator for this ongoing sponsored discussion on IT innovation and how it's making an impact on people's lives. Once again, we're focusing on how companies are adapting to the new style of IT to improve IT performance and deliver better user experiences and better business results. Our next innovation case study interview highlights how Axeda, based in Foxboro, Massachusetts, is creating a machine-to-machine capability for analysis. In other words, an Axeda Machine Cloud. We're going to learn how they do that and partner with HP in doing that. And we're joined in our discussion today by Kevin Holbrook, the Senior Director of Advanced Development at Axeda. Welcome, Kevin.
Thank you for having me.
The whole Internet of Things phenomena. People are expecting more and more devices, endpoints, sensors, even things within the human body delivering data out to applications and data pools. What do you do in terms of helping organizations start to come to grip with this machine-to-machine and Internet of Things data demand?
Sure. Well, it starts with the connectivity space. So our focus has largely been on OEMs, so equipment manufacturers. These are certainly people who have the M in the M2M or the T in the Internet of Things. So they're manufacturing things, and the initial driver is to just have a handle on those things. Basic questions such as, is this device on? There are multi-million-dollar machines that are currently deployed in the world where that question can't be answered without a phone call. So that was the initial driver, sort of the seed, if you will. So we entered into that space in the remote service angle, where we deployed small software, agent software, to the edge to get the first measurements from those systems and get them pushed up to the cloud so that users could interact with it. That grew into remote access, so think telnet sessions or remote desktop, being able to physically get down there, debug, tweak, and look at the device as it's operating. And then from there, we grew into software distribution or content distribution. Could be anything from firmware updates to physically distributing configuration and calibration files for the instrument. And we are recently seeing an uptick in content distribution for things like digital signage or in situ ads being displayed on consumer goods. So from there, we started aggregating data. We have about 1.5 million assets connected to our cloud now globally. And there's all kinds of data coming in. Some of it, very, very basic from a resource standpoint, looking at CPU consumption, disk space, available memory, things of that nature, going all the way through usage and diagnostics so that you can get a very, very granular impression of how this machine is operating. So as you begin to aggregate this data, all sorts of challenges come out of it. And HP has proven to be a great partner for starting to extract value. We can certainly get to the data, we can certainly connect the device, and we can aggregate that data to our partners or to the customer directly. Getting value from that data is a completely different proposition. Data for data's sake is not high value.
And so what is it that you're using Vertica for to do that? Are we creating applications? Are we giving analysis as a service? How is this going to market for you?
So from our perspective, Vertica represents an endpoint. So we have carried the data, cared for the data, made sure that the device was online, generating the right information, and getting it into Vertica. So when we're approaching customers, we're approaching it from a joint sale perspective. We are the connectivity layer, the instrumentation, the business automation layer there, and we're getting it into Vertica so that can be the seed for applications, for BI, for analytics. So to us, we are the lowest component in the stack when we walk into one of these engagements with Vertica. And then it's up to them on a customer-by-customer basis to determine what applications to bring to the table. And a lot of that is defined by the group within the organization that actually manages connectivity. So we find that there's a big difference between a service organization, which is focused primarily on keeping things up and running, versus a business unit that's driving utilization metrics, trying to determine not only how things are used, but how it can influence their billing. And we found that that's a place where Vertica has actually been quite a pop for us in talking to customers, because they want to know not just the simple metrics of the machine's operation, but how that reflects the business use of it. The entire market has shifted and continues to shift. I was somewhat taken aback only a couple weeks ago when I found out that you can no longer buy a jet engine I thought this was a piece of hardware you purchased, as opposed to something that you merely rented and paid per use. And so as the bigger machines, we've got GE as a customer. We have, the Bureau of Engraving and Printing as a customer. So we certainly have some very large machines connected up to our cloud. And we're finding that these folks are shifting away from the notion that one owns a machine and consumes it until it breaks or dies, but instead one engages in an ongoing service model wherein you're paying for the use of that machine. And while we can generate that data and provide some degree of visibility and insight into that data, it takes a sort of a massive analytics platform to really get the granular patterns that would drive business decisions.
Right. So it sounds like many of your customers have used this for some basic blocking and tackling about inventory and access and control, then moved up to business metrics of, how's it being used, how are we billing, audit trails, that sort of thing. And now we're starting to look at a whole new type of economy, a services economy based on cloud interactivity, whereby we can give granular insights and they can manage their business very tightly. So any thoughts about what's going to be required of your organization to maintain scale? The more use cases and the more success, of course, the more demand for larger data and even better analytics. How do you make sure that you don't run out of runway on this?
So I think there's a couple strategies we've taken. But before I dive into that, I'll say that issue is further complicated by the issue of data homing. So there's not only a ton of data being generated, but there are regulatory and compliance requirements which dictate where you can even leave that data at rest. So just moving it around is one problem. Where it ever sits on a disk is a totally different problem. So we're trying to tackle all of these. So the first way to address the scale for us, from an architectural perspective, was to try to distribute the connectivity. So in order for you to know that something's running, you need to hear from it. You might be able to reach out, which we'd call contactability, to say, hey, tell me if you're still running. But by and large, you know of a machine's existence and its operation by virtue of it telling you something. So even if a message is nothing more than, hello, I'm here, you need to hear from this device. So from a connectivity standpoint, our goal is not to try to funnel all of this into a single pipe, but rather to find where can I get a point of presence which is closest, which is reasonable. We've been doing this on our remote access technology for years, trying to find the appropriate geographically distributed location to route data through to provide it as easy and seamless an experience as possible. So that's the first, trying to, as opposed to just ruthlessly federating all incoming data, distributing the connectivity infrastructure, as well as trying to get that data routed to its end consumer as quickly as possible. So we break down data from our perspective into three basic temporal categories. There is the current data, which is the value you'd see reading on the dial on the machine. There's recent data, which would tell you whether or not something is trending in a negative direction, certainly pressure going up. But then there's the longer-term historical data. So while we focus on the first two, we rather deliberately, to handle the scale problem, don't focus on the long-term historical data. So I'll treat recent data as being anywhere from 7 to 120 days and beyond, depending on the data aggregation rates. So we focus primarily on that. Now, when you start to scale beyond that and where the real long tail of this is, we try to make sure that we have a partner in place to receive the data. We don't want to be diving into 2 years of data to determine seasonal trending when we're attempting to collect data from 1.5 million assets and acting as quickly as possible to respond to error conditions at the edge.
And what about, Kevin, the issue of latency? I imagine some of your customers have a very dire need to get analysis very rapidly on an ongoing streamed basis. Others might be more willing to wait and do it in a batch approach in terms of their analytics. How do you manage that, and what are some of the speeds and feeds about the best latency outcomes?
So that's a fantastic question. So everybody comes in and says, we need a zero latency solution. And of course, it took them about 2.5 seconds to say that. So there's no such thing as real time, certainly in the internet. Just negotiating up a TCP stack and tearing it down to send 1 byte is going to take you time. And then we send it over wires under the ocean, bounce it off a satellite, you name it. It's going to take time. So I think there's two components to it. One, accepting that near real time, which is the effectively the transport latency, the smallest amount of time it can take to physically go from point A to point B, absent having a dedicated fiber line from one location to the other. So we can assume in the internet that that's domestically somewhere in the 1 to 2 second range, and somewhere internationally in the 2 to 3 or beyond range, depending on the connectivity at the destination. So what we provide is an ability to produce real-time streams of data outbound. So you could take from one asset, you can break up the information it generates and stream it to multiple consumers in near real time in order to get the dashboard in the control center to properly reflect the state of the business, or to push it to a data warehouse in the back end where it then can be chunked and ETL'd into some other analytics tool. For us, we try not to do the batch ETLing. We would rather make sure that we handle what we're good at. We are fantastic at remote service, at automating responses, at connectivity, and at expanding what we do. But we are never going to be a massive ETL transform and converting into somebody's data model or trying to give deep dish analytics as a result of that.
Was it part of this need for latency, familiarity, and agility that led you to Vertica? What were some of the decisions that led you to pick Vertica as a partner?
I think it was a few reasons. That was one of them. The fact also that there's a massive set of offerings already on top of it. So a lot of the other people, when we went into and considered this, and I will omit mentioning competitors that we looked at, a lot of them were more a piece of the stack as opposed to a place where solutions grew out of. So it was not just Vertica, but the ecosystem built on top of Vertica. I will say that some of the vendors we looked at are currently sitting down in the partner zone, because they're now building their solutions on top of Vertica. So we looked at it as an entry point into an ecosystem, and certainly the in-memory component, the fact that you're getting no disk reads for massive data sets was very attractive for us, because we don't want to go through that process. We've dealt with the struggles internally of trying to have a relational data model scale, and I think that's something that Vertica has absolutely solved.
Now, your platform includes application services, integration framework, and data management. Let's hone in on the application services. How are developers interested in getting access to this? What are their demands in terms of being able to use analysis, outcomes, outputs, and then bring that into an application environment that they need to fulfill their requirements to their users?
So I think it breaks it down into two basic categories. The first is the aggregation, the collection of data, and the second is physical interaction with the device. So we focus on both with about equal weight. And I think when we look at what developers are doing, almost always it's the transforming of the data coming in and reaching out to things like a CRM system, opening a ticket when a device has gone and thrown a certain error code, or integrating with a back-end dropship distribution system in the event that some consumable has begun to run low. So in terms of interaction, there's been significant. On the data side, we primarily see that they're extracting subsets of data for deeper analysis. Sometimes this comes up in discrete data points. Frequently, this comes up in the transfer of files. So, there's a certain granularity that you can survive coming down the fire hose as discrete data points that you can react to, and there's a whole other order of magnitude of data that you can handle when it is shipped up in a bulk chunk. So good, for instance, is one of the use cases we have with GE in their oil and gas division, where they have a certain flow of data which is always ongoing, giving key performance indicators, but is nowhere near the level of data that they're actually collecting. They have database servers that are co-resident with these massive oil and gas pipeline generators. So what we do is provide them the vehicle for that granular data, and then when a problem is detected, automatically say, okay, give me far more granular data for the problem area, say 5 minutes before, 5 minutes since, which is then uploaded and we hand off to somewhere else. So when we find developers doing integration around the data in particular, it's usually when they're diving in more deeply based on some sort of threshold or some sort of trigger which has been encountered in the field.
And lastly, Kevin, for other organizations that are looking to create data services and something like your Axeda Machine Cloud, any lessons learned that you could share when it comes to managing such complexity and scale and the need for speed? What have you learned at a high level that you could share?
It's all going to be about the data collection strategy. You're going to walk into a customer or a potential customer, and their default response is going to be collect everything. That's not inherently valuable. So just because you've collected it doesn't mean that you're going to get value from it. We find that oftentimes 90 to 95% of the data collected in the initial deployment is not used in any constructive way. So what I would say is focus on the data collection strategy. Scale of bad data is scale for scale's sake. It doesn't drive business value. Make sure that the folks who are actually going to be doing the analytics are in the room when you're doing your data collection strategy definition, when you're talking to the folks who are going to wire up sensors, when you're talking to the folks who are building the device. Unfortunately, these are frequently within a larger business in particular, completely different groups of people that might report to completely different vice presidents. So you go to one group and they've got the connectivity guys, you talk about it, you wire everything up, and then 6 to 8 months later, you walk into another room, they say, well, what the heck is this? I can't do anything with this. All I ever needed to know was the following metric. And it wasn't collected because the two ends didn't touch. So I'd say that the success of deployed solutions and the reaction to scale challenges is directly going to be driven by that data collection strategy. Invest the time up front, and then you'll have a much better experience in the back.
Very good. Well, I'm afraid we'll have to leave it there. We've been learning how Axeda in Foxboro, Massachusetts is providing services to its customers through the Axeda Machine Cloud, and as a partner with HP is using their Vertica analysis platform to provide those insights. So I'd like to thank our guest. We've been joined by Kevin Holbrook, the Senior Director of Advanced Development at Axeda. Thank you, Kevin.
Thank you.
And a big thank you to our audience as well for joining us for this special new style of IT discussion. I'm Dana Gardner, Principal Analyst at Inter Arbor Solutions, your host for this ongoing series of HP-sponsored discussions. Thanks again for listening, and come back next time.